Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how the sun once went quiet for decades, raising questions about whether such a mysterious hibernation could happen again. To understand this phenomenon, scientists are now looking closely at patterns in the sun's activity over time. Our sun is going through an 11-year solar maximum, which means it also goes through a minimum during its life cycle. From 1645 until 1715, it went through a grand solar minimum, or the Maunder minimum. English astronomer Edward Walter Maunder was the one to discover this period, and so it was named after him. However, data from before this lull was needed to decode the cause of this solar dimming. Scientists from Nagoya University in Japan found a way to access data which could explain the Maunder minimum. German astronomer Johannes Kepler observed the sunspots in 1607 using a camera obscura, and scientists are reinterpreting this information to reveal what could have gone wrong with the sun for 70 years. The new study published in the astrophysical journal Letters reveals that sketches made by the legendary astronomer Kepler in 1607 solve a long-standing mystery regarding the sun's history. Maunder minimum was a strange 70-year period when sunspots almost completely disappeared, and Europe experienced the Little Ice Age. When Kepler observed the sun in 1607, he saw a dark spot and recorded it, and believed that what he was witnessing was a transit of Mercury. Later, he realized that what he was seeing was actually a sunspot group. His pinhole projector captured the oldest known drawing of a sunspot made with a scientific instrument. Researchers mapped Kepler's spots by using Spurer's law, which tracks how sunspots migrate from the sun's poles toward its equator over an 11-year cycle. They determined the spots were at a low latitude, meaning the sun was at the very end of a solar cycle in 1607. What scientists needed to understand was if the solar cycles before the Maunder minimum were normal, or whether there were telltale signs, such as unnaturally long or short cycles, signaling the coming shutdown. Kepler's data proves that the cycle ending around 1607 was of a regular length. By situating Kepler's findings within broader solar activity reconstructions, scientists gain crucial context for interpreting changes in solar behavior in this pivotal period, marking a transition from regular solar cycles to the grand solar minimum, Hisashi Hayakawa, the lead author of the study, said in a statement. The findings offer an insight into the warning signs of a grand solar minimum. The study confirms that the sun was behaving normally right before it entered the Maunder minimum, indicating that these deep solar hibernations can occur without dramatic, long-term changes to the cycle's duration beforehand. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.